Hello, made it to the end of the week again, well done. So we're continuing our work on fractions today, and we're going to look at fractions for our starter as well. So first of all, we need to try and work out which is bigger out of 7/11ths or 2/3. Now that's kind of tricky to work out, because when we think about 7/11ths and 2/3, they are kind of a similar size really. They're both more than half. So can you think of a way that we could compare these to actually work out which one's bigger? Well, what we could do is create equivalent fractions, and then we'll know for a fact which one's bigger. So like the work we were doing yesterday, let's find a common denominator. So the 11 times table. If we go up the 11 times table till we find a number that's in a 3 times table, we're going to arrive at 33. So we're going to put both of these fractions over 33. Okay, so creating our equivalent fractions, we've multiplied 11 by 3 here, so we need to multiply the 7 by 3 as well. So that's going to give us 21 over 33. And then the next one, the other fraction, if I look there, we've multiplied the 3 by 11 to get 33. So the 2 needs to be multiplied by 11 as well, and that'll give us 22. So now we can see clearly that those fractions are very similar in size, because one's 21 over 33 and the other one's 22 over 33. So the bigger one is the 22 over 33, so it's 2/3 that is a little bit bigger. Okay, we're going to do the same sort of thing here with 5/9 or 3/5, exactly the same process. So common denominator, the first number we come to that is in the 9 times table and in the 5 times table is 45. So we've multiplied the 9 by 5, so we need to do the same to the top, so that gives us 25. Then we've multiplied the 5 by 9, which we need to then multiply by 3, so that gives us 27. So we can see, again, these fractions are very similar in size. One's 25 45ths and the other one is 27 45ths, so that one is a little bit bigger. Okay, so let's have a look at, again, where we're at and where we're heading. So we're still on adding and subtracting fractions like we started yesterday, but today we're going to do mixed numbers. So recapping on yesterday's work, we'll just do these couple of examples. So we've got, to start with, 3/4 add 1/3. So from yesterday's work, we can remember that we need to make a common denominator, and that has to be the lowest common multiple of 4 and 3. So like we were just looking at in the starters today, we can remember that the smallest number that's in the 4 times table and the 3 times table is 12. So 4 has been multiplied by 3, so the 3 also needs to be multiplied by 3. The 3 has been multiplied by 4, so the 1 has to be multiplied by 4. So altogether we've got 13 over 12, and if we write that as a mixed number, it's 1 and 1/12, because it's a top-heavy fraction, or an improper fraction. Okay, so the next one is a subtract, but we do it in exactly the same way. So we need to find the lowest common denominator, and because 4 goes into 8, then the lowest common denominator is 8. So we haven't done anything with the first fraction here on the bottom, so we don't do anything with the top either. And then the second one, we've multiplied the 4 by 2, so we multiplied the 3 by 2 as well to give us 6. So we've got 7/8, take away 6/8, leaves us with 1/8. Okay, now let's think about mixed numbers. If we're thinking about 2.5 add 3 1/3, we've basically got two choices here. We can either keep the fractions simple by dealing with the whole numbers first, or we can change the mixed numbers into improper fractions. Okay, so I'm going to show you a couple of examples of doing it each way, and then you can decide which way you think is best. Okay, so first of all, we're going to do this one where we deal with the whole numbers first. Okay, so we still need to change the fractions into equivalent fractions. So we're going to do that before we do anything else. Okay, so we've got 3 and something, add 4 and something. So let's just change the fractions. So we're looking at 4 and 5 in the denominator. So the lowest common denominator, or the lowest common multiple of 4 and 5 is 20. So we need 20 on the bottom there. And then, so forget about the 3 and the 4 because we've already got them. So the 4 has been multiplied by 5. So the 1 needs to also be multiplied by 5. And then the 5 has been multiplied by 4. So the 3 needs to be multiplied by 4 to give us 12. So now we do what I'm talking about doing the whole numbers first. So what we've got is 3 add 4 is 7. And 5 20ths add 12 20ths is 17 20ths. Okay, so all we do for this method is we leave the whole numbers as they are whilst we create equivalent fractions, and then we go straight to the answer. Okay, let's do that using equivalent fractions this time instead. Improper fractions. So, same question. So we're going to change each of these into improper fractions before we start. So remember the way we do that. You do that times that, add that to go on the top. So 4 times 3 is 12, add 1 is 13. So I've got 13 over 4, add. Then we do 5 times 4 is 20, add 3 makes 23. Okay, so we've got 13 over 4, add 23 over 5. So now we need to create our equivalent fractions. And like we've already talked about in this question, the common denominator for 4 and 5 is 20. Okay, so 4 has been multiplied by 5 to give us 20. So we need to do 13 times 5 on the top here. So 13 times 5 is 65. Then the second one, 5 has been multiplied by 4 to give us 20. So we need to multiply 23 by 4 to go on the top here. So 23 times 4, if you double it and double it again, you get 92. So we've got now 65 over 20, add 92 over 20. So that is 157 over 20. Okay, and if we change that into a mixed number, if we go to 20 times table, then 7 20s are 140, which leaves you with 17 20ths. Okay, now I don't know what you think, but I certainly think that this is more straightforward than that. I think in this one we've got more processes to go through, the numbers are bigger, we've got more tricky calculations, and I just think to do with the whole numbers first is a bit more straightforward. Okay, we'll see how it works with subtracting, just exactly the same, except for in a case that we're going to come across soon. So let's do this in the two different ways. So first way is we're going to leave the whole numbers as they are, and we're going to change the fractions so that we've got a common denominator. So we're going to change the half and the 2/7. So the smallest number that's in the 2 and the 7 times table is 14. So we're going to have both of these over 14. So 2 has been multiplied by 7 to get 14. So the 1 needs to be multiplied by 7 as well. Then the 7 has been multiplied by 2 to give us 14. So the 2 needs to be multiplied by 2 to give us 4. Oops. Okay, so let's deal with the whole numbers now. 8 take away 3 is 5. 7 14ths take away 4 14ths is 3 14ths. So that was nice and easy. Okay. I hope you can see that the numbers are going to get a bit awkward if we change these to improper fractions. We'll go through it, but we might decide halfway through that actually it's too fancy and we prefer the other way. Okay, so let's go for it. So we're going to change 8.5 into an improper fraction, so that gives us 15/2. Then 3 2 7ths, 3 7s are 21, add the 2, makes 23. So we've got, oh, did you spot that strange mistake I made there? The 8 2s are 16, add 1 is 17, not 15, silly me. So we've got 17/2, take away 23/7. So none of those numbers are particularly nice or sit comfortably with us, do they? So we're going to do our common denominator. So common denominator for 2 and 7 is 14. So to get the number that goes here, well, we've multiplied the 2 by 14, by 7, sorry, to get 14. So we multiply 17 by 7 to get the number that goes on the top here. So we're probably going to have to do this at the side. So 7 7s are 49, 1 7 is 7, add the 4, makes 11. So that's 119/14. Okay, second one's a little bit easier. The 7 has been multiplied by 2, so the 23 need to be multiplied by 2. So 23 times 2 is 46. So we've got 119/14 minus 46/14. So we need to do 119 take away 46. So 9 take away 6 is 3, 11 take away 4 is 7. So that gives us 73/14. And if we work out how many 14s are in 73, there are 5. 5 14s is 70. So we've got 3 left over. So I hope you can see that changing to improper fractions does work, but it is more work. Okay, we had the multiplication we had to do, we had the subtraction to do. So I don't think, in my opinion, this is not the best way to do this. I prefer you to use the whole numbers. Okay, so let me show you now what happens sometimes though when you're subtracting. All right, so the whole numbers method will always work, okay, for your adding. But for your subtracting, sometimes there's a little problem, and we'll see what it is with this one, okay? So let's make this a bit bigger. Okay, so we're going to keep our whole numbers just now and create our equivalent fractions. So we've got 4 minus 1. Okay, so we're going to find now our common denominator for 5 and 10. That's going to be 10. And we've multiplied 5 by 2, so we need to multiply the 1 by 2. And then we've not done anything to the 10, so we don't do anything to the 3. So what we're going to find is that we do 4 take away 1, so that's 3. But then look at this, we're taking away, and if we look at the fraction parts of these, we're taking away more than we started with. We're doing 2/10, take away 3/10. But instead of panicking, if we just think, right, well, 2/10 take away 3/10 is minus 1/10, then we've only got one more step to go. So 3 whole ones take away 1/10 gives you 2 whole ones, and you've still got 9/10 left. Okay, so even though the second fraction is bigger than the first fraction, we can still do it in the same way as we were doing the other ones. It just means we've got an extra little step at the end, because when you do 2/10 take away 3/10, it's a negative. Okay, if you were doing that as improper fractions, I'll just quickly show you. So 4 5s are 20, add the 1 is 21, and you'd have 13/10. So your common denominator would still be 10s. you'd multiply the top by 2, and you'd leave that top as it is. You'd have to do 42 take away 13 is 29, so that's 2 9/10. Okay, so that's a fairly straightforward example, but we can see that the numbers in the fractions stay smaller and more manageable if we stick to using the whole numbers, not the improper fractions. Okay, so the next one. We'll keep the whole numbers. And we'll find our equivalent fractions now for 2/3 and 8/9. So 3 and 9. Common denominator is going to be 9 because 3 goes into 9. So to change thirds into ninths, we've multiplied the bottom by 3, so we multiply the top by 3. And then to change ninths into ninths, well, we don't do anything, do we? So it's just going to be 8. Okay, so what we can see here is that we've got, if we deal with the whole numbers, 3 take away 2 is 1, and 6 ninths take away 8 ninths, so 6 take away 8 is -2, so we've got -2 ninths, and 1 whole 1 minus 2 ninths. Remember that there are 9 ninths in a whole 1, so that would leave us with 7 ninths. Okay, so that one doesn't even end up as a mixed number. But again, looking at the numbers here, if we're making equivalent fractions, we'd have 11 over 3, take away 26 over 9. So that would give us 33 over 9, take away 26 over 9, which is 7 over 9. Okay, so we get to the same answer. In this particular example, the numbers were not too tricky at all. Okay, so we're going to do one more. We might not do the bottom one, I might just leave that one for you to do. Okay, I think we've probably done enough. So, last one then. 4 and a 6 take away 3 1/4, so it's going to be 4 and a fraction take away 3 and a fraction. The lowest common denominator, if we've got 6 1/4, is going to be 12ths. So making our equivalent fraction here, 6 times 2 is 12, 1 times 2 is 2. 4 times 3 is 12, 3 times 3 is 9. So we've got 4 take away 3 is 1, and then 2 12ths take away 9 12ths gives us -7 12ths. And remember, there are 12 12ths in a whole 1, so if you take away 7 of them, you've got 5 left. Okay, and that's all I'm going to show you today. What I'm going to do is pause it just now, do the last one, so it will just appear in a second as if by magic. Ta-da, there you go. So I'll set you some of these to practice, and you can give me a shout if there's anything you're not sure about. Okay, see you later.